You can see my screen, right? Okay. Hi, everyone. Welcome to today's webinar, where Dr. Guokan and Yousef will be introducing Atlas Chat, the first collection of large language models specifically designed for Moroccan Arabic Darija through a carefully created data set and quality control translations that was done by a community called Atlas AI. And Atlas Chat models 9B and 2B excel in Darija-specific tasks, outperforming leading Arabic LLMs, and this project sets a new benchmark for instruction tuning in low-resource languages, and all resources are openly available. Dr. Guokan is a lead research scientist at MBZUAI France Lab with a PhD from École Polytechnique. His research focuses on NLP, particularly the long-term effects of synthetic text on models and humans. And we have also today as our speaker, Yousef Khoubrane. Is an industrial management engineer and data science specialist from EMI, Université Mohammed VI Polytechnique. His work spans NLP, LLMs, and graph machine learning with a focus on instruction tuning for Darija. He has collaborated with institutions like Linagora, Embezed UII, and University Technology Mara on various AI research projects. The presentation will last for 30 minutes, followed by a 10-minute Q&A. And if you have any questions during the talk, please feel free to ask them in the chat, and we'll be sure to address them at the end of the presentation. And thank you for accepting our invitation, and please, the floor is yours.
Maybe Yousef can you share the screen? Yeah. So thank you, Iman, for the introduction. And hello, everyone. Thank you for joining this session. I'm Guokan Shang from MBZUI France Lab. It is an AI research center in Paris affiliated with Mohammed bin Zayed University of Artificial Intelligence, which is in Abu Dhabi. It's my great pleasure to present Atlas Chat at MoroccoAI with Yousef Khoubrane, a graduate student of UM6P who has done his internship in collaboration with us. So led by MBZUI, this project also received contributions from the other organizations, including Linagora, KTH, École Polytechnique, along with the support of Atlasia community. In this talk, we will walk through the stages of development and the challenges we have faced in creating Atlas Chat of 3 sizes, 2B, 9B, and 27B, which is the first collection of LLMs developed for Moroccan Arabic, also known as Darija. I'll start by giving a brief introduction, followed by our data preparation process. Then we will explore the model development steps, then evaluation methods and metrics, and finally a conclusion. Large language models, or LLMs, have shown impressive results across various languages. The development usually consists of 2 stages. The first is pre-training, which teaches an LLM general language patterns from massive datasets, building a broad linguistic foundation or understanding of the language. And then the second phase is fine-tuning. It specializes the model, refining it for specific tasks or languages. We saw that existing models, like both closed source like ChatGPT and open source model like Llama, primarily focus on data-rich languages, leaving low-resource language behind. Okay. Furthermore, we know there are some Arabic-specialized models, such as JAIS and HGPT. They are optimized only for modern standard Arabic and overlook Arabic dialects. However, we know that MSA differs significantly from dialects. So there is a real need to create LLMs for Arabic dialects. and our work focuses on Moroccan Darija. One of the main challenges with Darija is that despite being spoken by millions in Morocco, it remains primarily a spoken dialect with limited formal resources. Also, Darija lacks standardization and can be represented in both Arabic and Latin script. Next slide. So in the next, I'll talk about data preparation, where we placed a significant focus. But before we dive into specific data sets, there are some preliminary decisions to make, right? Such as the model should be Darija only or English Darija bilingual, right? And whether we should train from scratch or otherwise. So the first decision we make is the atlas chart should be Darija-centric and monolingual. That means we focus on developing a model that accurately understands prompts written in Darija, generates Darija content, respects its cultural context, and remains accessible and adaptable for native Darija speakers. And the second decision we made is we choose to use instruction training on a base model rather than training from scratch. This decision was primarily because that the training an LLM from the scratch requires extensive data, which is not readily available for Darija yet. This decision directed our efforts towards creating an extensive and diverse and high-quality Darija dataset for instruction training. We construct our instruction training datasets by consolidating existing native Darija datasets, creating novel synthetic Darija datasets, and translating English instructions to Darija with quality control. By combining these different sources, we aimed to enhance the model's ability to understand and generate Darija across various contexts. So in the end, we compiled over 458K samples for instruction training. For the native data, we basically reviewed all previous research in Darija NLP and collected in the end 10 data sets that met our quality standards over 4 tasks, such as translation, it's Darija to English, to French, to MSA, and vice versa. So in total, we have 6 translation directions. And second task is transliteration. So we do the conversion between Darija in Arabic script to Latin script and vice versa. And the third one is sentiment analysis. So those are data set about classify Darija sentences into a positive, negative, or neutral label, And the last task is news summarization. And specifically for the translation data task, we created a new data set in this project named DODA 10K, based on the original DODA corpus. DODA 10K dataset includes translation quintuples, that means 5 parallel sentences, between Darija in both Arabic and Latin scripts, MSA, English, and French, So it should be very useful for future research in translation involving Darija. And this dataset was extensively reviewed by groups of native Darija speaking annotators to ensure the quality of the entire dataset. For the next, I'll let Yousef to present.
Thank you, Guokan.
Thank
you. Do you hear me well? Guokan? Yeah, okay.
Yes.
So for the remaining of the presentation, we'll present translated English datasets. So due to the lack of readily available Darija native data, we needed to translate some English datasets. We finally opted for Tulu V2 mixture because it already includes lots of widely used data sets like FLAN, ShareGPT, and others. It has a proven performance because V1 was empirically tested, and models trained on it were far more performant than other models. And then V2 outperforms V1 in the same empirical way. Tulu V2 mixture consists of let me hide this screen. Okay. It's formatted as messages format, which is a list of JSONs where each JSON contains two fields, role and content. Role can be either user, assistant, or system, and content is the content of the message. Then for the translation model, we experimented with the open source and closed source models. We noticed that closed source models outperform open source models by a large margin. And then other than that, they keep the key formatting like backslashes and tags. And among all of them, Claude 3.5 Sonnet was the best performing. So we invoked this model using its API via Amazon Bedrock, and we used Asensio to handle multiple requests at the same time. So we translate 25 messages at the same time. Then for the translation, we used this prompt. It asks the model to translate the content to Darija while following some guidelines. Those guidelines ensure that the model knows how to handle some specific cases, like when it comes across a word that doesn't exist in Arabic, or when it comes across code that it shouldn't translate, or other keywords. Then for pre-processing the dataset before translating, we excluded the science subset because it's too technical for our use case. We removed translation tasks because if you translate some translation tasks, the original one will be French sentence, Darija or English sentence. If you translate the task, it will be Darija to Darija, so it's nonsense. So we excluded the translation task, and then we used a Facebook language identification model to identify all sentences that had too many English no English examples, and we removed them. Then after translation, we post-processed the translations by replacing non-translated keywords like input. It was kept in English, so we translated it to Mu'tayat, and output to Natija, and so on and so forth. We also removed excessive English content. So when the model doesn't translate an instruction and keeps it almost all in English, we removed it. So from all Tulu V2 mixture, only 49% of the original was kept in Tulu Darija. Then we pass to synthetic datasets. First, Moroccan Wikipedia QA. This is a dataset created from the Moroccan Wikipedia. We scrap it via Wikicorpus from Gensim, and then we generate QA pairs based on 4 tasks. The first task is OpenQA, which contains question and answer. Extractive QA adds a context, and the answer is based on this context. Multiple choice QA has multiple choices, and the answer is the index of the correct answer. And multiple choice extractive QA combines the 2 previous tasks. So the distribution of these tasks is as follows. So as you see, we focused more on multiple choice QA and multiple choice extractive QA because those 2 types are the most used in evaluation benchmarks. Then we pass to Moroccan social media multi-gen. The starting point was Kadi dialect identification dataset and some Darija specific keywords that only exists in Darija, or mostly exist only in Darija. like كتشوف كيضحك داك الشيء. Most of the time it's only in Darija. We use the Twitter API to scrap all the tweets from based on these IDs and the keyword search. And then we added the OMCD dataset, which contains some offensive YouTube comments. We had a dataset of tweets and YouTube comments, which was converted into QA pairs based on 6 tasks. The 6 tasks being safe response is reserved for YouTube offensive comments, because we generated some responses to potentially offensive content so that the model can be trained on that. These are some of the prompts given to generate those QA pairs. For continuation, you ask the model to continue to consider the tweet as an incomplete tweet and continue it. Replying is asking the model to reply to the tweet, being the person to reply. Summarization, summarize the content, rephrase, or explain. And for safe response, you ask the model to consider this tweet or this YouTube comment as a prompt from or an offensive prompt from the user, and answer it politely. Then you can see that to ensure a good quality of the generations, we used some 1 or 2 examples given. So we'll talk about that later in a few short examples. Then we have Darija story completion. So generally, when we want to fine-tune a LLM on some tasks on a language or a dialect, we use first continue with the pre-training, and then we fine-tune after that. But for continued pre-training, it needs a large amount of data. So the problem was the lack of sufficient Darija pre-training data. So we cannot even continue with the pre-training. The solution is to introduce an instruction tuning dataset that enhances the next word prediction in Darija. So it's like just a small instruction tuning dataset that plays a similar role to continue with pre-training. How we constructed it is from qessa.com website of stories in Darija. We scrapped more than 4,000 stories, and each story was segmented into multiple segments. Each segment is further segmented into a snippet, which was considered as a prompt, and a completion, which was considered as a response. And during the fine-tuning, we will calculate the loss on those responses, so it will enhance the next word prediction capabilities of the model. And for the resulting dataset, it contained almost for 49,000 instructions. Then we added some hard-coded samples, which ask the model questions like about its identity, like who created you, what is your name, and such. For example, you can see here واش تقدر تاخذ بلاصة جوجل، واش انت احسن من تشات جي بي تي, and such on. So those are hard-coded questions to give the model how it will answer such specific questions. Each of these prompts was repeated 10 times to reinforce the memorization of those answers. Then we converted all data sets to prompt responses. For translation, we just have the source language, and we tell the model to translate source language to target language, and the translation being the response. Transliteration, almost the same thing. You just ask the model to write the same sentence in write the same sentence in the other script, so from Latin to Arabic or from Arabic to Latin, and so on and so forth. Those tasks were all converted to zero shot, few shot, or multi-turn. So 80% of the data was just in zero shot format, and 10% was in few shot and multi-turn. A few shot means that you give the model some examples to show it how it answers before giving it the question. This is an example of a two-shot prompt. Then we pass to the model development. First, we had to choose the base model to fine-tune. So we went to the Open Arabic LLM leaderboard because Arabic remains the closest language to Darija. Why? Because of two things. Because Darija has a lot of vocabulary that comes from Arabic, and then we trained the model on Darija in Arabic script. So Arabic script is the closest to Darija. We filtered by model size less than 50 billion, and we found that most of the models that are at the top are based on Gemma 9 billion. We can see that even the models that are not Gemma based on Gemma 9 billion are have more than 10 or more than 12 billion parameters. So we can see that models trained on Gemma 9 billion outperform other models in Arabic. So we know that this base model is good for Arabic, and we can see that Cinema 9 billion, which was based on Gemma 9 billion, even outperforms 72 billion models. So this gives us more credit to our decision. So the base model was chosen to be Gemma 2. After that, we had to choose between full fine-tuning or LoRa, low rank adaptation. So full fine-tuning is training all the weights of the model, and full fine-tuning is adding some components to each of the weight matrices and only training those components which are of low rank. So they represent far less parameters compared to full fine-tuning. So LoRa learns less but forgets less. This is the difference between the two. When we tried Gemma 9 billion we experimented between full fine-tuning and the LoRa. We noticed that with LoRa it outperformed. It was more effective in our case because full fine-tuning resulted in catastrophic forgetting, where the model forgets some of its pre-trained knowledge due to fine-tuning, to excessive fine-tuning. Then we pass to the training framework. We have trained the model on 8 NVIDIA A180 gigabyte GPUs used in parallel. We used OS SageMaker, and we used FSDP for fully sharded data parallel training because it reduces GPU memory per usage. Then for the training hyperparameters, the goal is to balance memory efficiency, training speed, and model performance. For LoRa configuration, we used a rank of 256 and the alpha of 182. We trained for 3 epochs with a learning rate of 5 to 5.10 to the power of -5. A warm-up ratio of 3% and other most importantly, we have the max sequence length of 2000 tokens. This is to show what does the rank and the alpha in LoRa hyperparameters mean. The rank is the rank of those matrices. So you map the impedance size to the rank of the LoRa space, and the alpha is the constant here. After that is multiplied to W up, down, and HI. We also used brain float 16 instead of float 32 because it's more efficient because it takes less memory, almost half the memory of float 32. So finally, we pass to evaluation. First, for evaluation benchmarks, we have a set of benchmarks constructed or translated. Darija MMLU is a translation of subsets from MMLU and Arabic MMLU. Its tasks are multiple choice ones with or without context. It evaluates general knowledge. We have also Darija Helaswag, which is a translation of Helaswag validation set. It's more about sentence completion. You have one sentence as the prompt and 4 completion choices. So it evaluates common sense reasoning and machine reading comprehension. So the model needs to select between those close sentences to know which one is the best completion. We have the Bilibili data set that has a subset in Darija. So it was already in Darija, we didn't translate it. It is multiple choice QA with context, and it also evaluates general knowledge based on Wikipedia. We have Darija Bench. This is a dataset or a benchmark that we created ourselves. It consists of test sets from those native Darija datasets that we trained the model on. They include translation, sentiment analysis, summarization, and also transliteration. They evaluate model performance on Darija understanding because those are 4 Darija-specific tasks. And we have Darija Alpaca Eval, which is a translation and cultural adoption of Alpaca Eval. It's more about open QA, and it evaluates instruction following. For the framework of the evaluation, we used LM evaluation harness. This is a GitHub repository where you add your tasks, and inside the tasks you specify some information like the path of the benchmark dataset. Here is Mbizway, Paris, Darija, Helaswag, for example. You also specify the type of the output. For Darija Helaswag, it was a multiple choice, and so on and so forth. So you specify how those documents are processed, and you specify how the choices and the answers are selected, and then you specify also the metric and the aggregation method. Then once you have your task done, you just run the command lmeval, and you select the model, whichever model from Hugging Face. You put it here in pre-trained, the data type. You add all the tasks that you want, and you specify some other parameters, and you run the command. So how does this evaluation harness works? For example, for multiple choice QA, the input format is a list of a prompt choice. So the model, for example, if we have 4 choices, the model has 4 sentences. Each sentence consists of a prompt and one of those choices, and then it calculates the logits of each sequence, prompt plus choice, and it takes the argmax of all those log likelihoods, and then it scores using the metric we specify. For example, here it's accuracy or other metrics. And then for the metrics, we have 6 metrics in total. We have accuracy, which is just the proportion of correct predictions. We have a blue score and rouge score. Blue score almost most of the time used for translation, and the rouge score for summarization. But for blue score and rouge score, they use word engrams, which is a little bit of a problem for Darija, because like in some words you have the same word can be written in different ways. So like kidair and kidair and kidair, the same word can be written with a space between ki and dair, or with the alif or not. So we also added character-based F-score. This character-based F-score compares the target and the candidate translation or summarization based on character engrams instead of word engrams. That's why it's better in our case. We also added BERT score, which uses contextual embedding from BERT to measure the semantic similarity instead of the character or word similarity. And we have LLM as a judge, which in which you give your generation to a strong LLM like GPT-4, and you ask it to evaluate the quality of the generation. Maybe you can compare it to one other generation from other model, or you can compare it to some human response or some baseline. So here we have the results. We can see that Atlas Chat 27 billion outperforms all models in almost all benchmarks, except for sentiment analysis. We have Atlas Chat 9 billion that comes first, and then we have Atlas Chat 2 billion, and the larger model comes last. In all other benchmarks, Atlas Chat 27 billion comes first, and in most of them, Atlas 9 billion comes second. And even compared to larger model like Jai's family 30 billion and Gemma to 27 billion, Atlas Chat 9 billion comes second. So this is impressive results. We also have the LLM as a judge results. So you have the news summary, the news article summaries. You have a news article and its title as a summary. So that title was originally written by a human. You asked each of the models to generate a new summary based on that news article, and you ask a strong model. In our case, it was Claude Sonnet 3.5 to compare between that human reference and the generation of the model. So these are the results. So Atlas Chat 27 billion outperformed the human baseline 60% of the times. Atlas Chat 9 billion and 2 billion come second and third, and the other models have a very big gap between to the three best models. So here we have some perspectives and before the conclusion. So this is Atlas Chat in action. We asked it about the advantages of renewable energy. شنو هي الإيجابيات ديال الطاقة المتجددة, and it answers very well. These answers are from Atlas Chat 9 billion. Then we asked it about the moral from this short story, and it answers well. But those are the good generations of the model. Yes, it sometimes generates some bad generations. For example, here we asked it about Samat Hassan, and it said that Samat Hassan is a territorial community somewhere in Casablanca, which is not true. And here we asked it to translate I love programming to Darija, and it translated it to Kan بغيك programmage, which, well, it's not the best translation. So the problem here is hallucinations. The answers are relatively in proper Darija, but the information is not correct. This applies more to the first generation. And the solution is introducing a bigger model, because those generations were first done by Atlas Shot 9 billion. So we introduced Atlas Shot 27 billion because almost all, whenever you have a space or a chatbot interface, you will have a model with more than 30 billion parameters. So chat models need to be based on large models to be performing like considerably. We saw in the previous results that Atlas Shot 27 billion performs better, and then here comes the conclusion with Guokan.
Thank you, Yousef. Yes, as a conclusion, so Atlas Chart model as the first LLM specifically developed for Darija. And actually, in general, I think we are the first that develop LLM for dialectal Arabic. And second, we construct a comprehensive instruction tuning dataset for Darija. We call it Darija supervised fine-tuning mixture. And we also have a new evaluation suite, right? Contains a lot of benchmarks, okay, includes both discriminative and generative tasks. And in the end, our model outperformed the state-of-art and Arabic-specialized LLM in following Darija instructions and executing standard NLP tasks like summarization, sentiment analysis. So I believe these contributions pave the way for future efforts on Darija LLM development and for LLM adaptation to low-resource languages or dialects. And in the end, all our resources we mentioned here, including training data, models, and benchmarks, are all publicly available on our Hugging Face account at MBZUAI-Paris. So we believe our work establishes a foundation for future Darija LLM development. Maybe, Yousef, you can show a bit about our demonstration that we deployed on Hugging Face space.
Yes, this is demonstration of okay. So here it comes. This is the space. So it's based on Atlas Chart 9 billion, because 27 billion is too large and consumes too much resources. So we give it some of those predefined prompts. For example, شكون اللي صنعك, or yeah, we can start with this. And we see that it answers, yeah, it's like those hard-coded examples that we gave it to ensure that it answers those identity-related questions. For example, we can ask it to translate. Well, it translated its name a little bit wrong, Atlas instead of Atlas. But yeah, Atlas Chat is the first open language model that talks in Darija. Atlas Chat هو أول نموذج لغوي كبير مفتوح المصدر open source كيهضر بالدارجة, so it's relatively good. We delete this because if you keep if you keep adding messages, those previous messages will be taken into account. So we don't want that. So we ask it about شنو كيميز المملكة المغربية. What is specific about the Moroccan kingdom? And it answers المغرب كيميزو بزاف د الحوايج منهم التنوع الثقافي، التراث التاريخي and المناظر الطبيعية، الماكلة ضروري الماكلة. Food is and then we have الناس. You can keep asking to add to the same context. For example, I'll try asking it in English. Which of these points do you love the most? So it says that as a artificial intelligence, it doesn't have emotions or preferences, but if it had to say, it will say the cultural diversity تنوع ثقافي and تراث تاريخي. Yeah, so it said all of that, but yeah, this is just a demonstration that you can add to the same conversation, add more terms, and it will take previous context into consideration in answering. So here we asked it with which of these points, so it remembers that these points refer to the answers that it gave. So yeah, that's it. You can play more with the interface here in Hugging Face if you want.
Yeah, the link is very, you can easily find the link on our Hugging Face home, right?
Yes.
Thank you so much.
Yes, it's here, and you can find models and data sets. Yeah.
Thank you. If you can share with us the link in the chat.
Yeah, okay, of course.
Thank you.
Yeah, let me just do it. Yeah.
I shared it.
Oh, okay.
Thank you, Guokan and Yousef, for this insightful, detailed talk that you made us walk through the behind of the scenes of developing the Atlas chat. And we really enjoyed listening to all you have been through to develop this amazing LLM. So we have here a couple of questions. Many you answered through the presentation. It was very detailed and to the point. So I will we have some other questions. So I will start by this question, which is an important one, which it's about the financial cost. So we know that training from scratch, like you mentioned, is very costly, it's expensive. So for doing this instruction tuning, how was the financial cost to do this fine tuning to the models?
I think I cannot tell about the exact amount, but I can say we have tried our best to use like cost-efficient approach, right? Like we adopted a LoRa, right, rather than full fine-tuning. On this, also we go with instruction training rather than pre-train from scratch. So I don't know if Yousef have other points to add, but these are what I can say.
Yeah, the same thing. Even for when you used Amazon Bedrock instead of using the Cloud API directly, so it reduces the cost and such.
Okay, thank you for the clarification. And another question from an attendee, he's asking about how many data did you need to do this tune instruct for the LLM? Like if you want to replicate the methodology approach to other dialects, how many data we should have to do this?
It depends. For For instance, depends on which development stage you will need. Whether you'll need pre-training, right? Whether pre-training from scratch, whether you will take one existing LLMs and do continue pre-training, right? To do language interpretation, whether there is a step for instruction tuning, then you need to construct the instruction tuning dataset. Whether you will do the last one is reinforcement learning from human feedback, right? Whether you will do alignment tuning. So this is a pipeline, right? We can do part of it. I mean, it depends on which part you will do it, or the entire pipeline. Specifically for this Atlas chart, we only do the instruction tuning dataset. It took us, let's say, 6 months of collecting data, design the instruction template, create synthetic data, and translate English data sets.
The dataset at the end included 458K samples, but for each sample we have the question and the model response, and sometimes a sample contains multiple turns or a few short examples. So if you go to MBSY Paris Hugging Face page, you can go to the data set and, for example, compute the mean length of each sample. You can calculate the number of all tokens used for training.
Thank you for those awesome answers. So we still have here some questions. We have a question about the duration. You just mentioned that it took like 6 months to collect data. We have a question that is asking how does it take to fine-tune the model? I mean, based on their respective sizes, and what were the main challenges that you encountered meanwhile developing Atlas Chat?
I think the main challenge is about data-wise mostly. I mean, basically we reviewed all previous NLP research in Darija. So you need to check all the historical NLP papers in Darija, right? And whether this paper released this data set, where to find it. And this data set are in different formats, in XML, in JSON, or even in CSV.
Yeah.
It contains all kinds of formats and noises, and so we need to really review it, right? And standardize this data set. And also, like one frequent question we ask is, I always ask whether this sentence is MSA or Darija, or a mixture of Darija and MSA.
Yeah. Because Moroccans in social media use a mixture of both. So sometimes it's all MSA and sometimes it's mostly Darija. So that's a problem.
Yeah, some Darija data set claim it's Darija, but we asked Yousef to review it. Actually, it's 99% MSA, so we cannot use it, right? So I think this all process of data like collection and creating is the most challenging part.
Yeah, and for the training, the fine tuning, did it took long to fine tune the models, or it was more to gather data, and training was quite straightforward and quick?
Yeah, training is quite straightforward and quick. For instance, we use especially we use LoRa, and we use 880 gigabytes, and it took us like less than a week, I can say. 3 or 2 days. Yes, less than a week you can have the model.
Okay, so the challenge was coming up with a good quality data set.
Yes, I only talked about the training data, but also we have benchmark data sets, right? It's also another line of data sets.
Thank you for your answers. So we have another question regarding the hyperparameters that you showed us in a slide. Were these hyperparameters chosen from the literature, or did you use some specific strategy to set those hyperparameters?
Let me find that slide. Yes. So basically, like a hyperparameter, I think it's our second author, Hadi Abdin, who is the most
Yeah.
familiar with these selections. Unfortunately, he is not here with us today. But yes, some like hyperparameters, for instance, LoRa rank. Okay, we have tested. We have done some few settings. Like now we use 256. We have tried, I think 64.
100, yeah, 108 to
128.
828.
Yes. And for LoRa Alpha, I think it's the mostly depends on the literature. Actually, it said LoRa Alpha can be either double or half of the LoRa rank, right? And Epoch 3, I think it's just a common practice.
Yeah.
And the others, I think, are mostly straightforward. Yeah, warm-water ratio and etc.
Thank you. So we still have 3 questions and we will wrap up the Q&A session. And we have a question, like we said, that in the data sets found in the literature, they are mainly mixed. And we have a question regarding that, like how the Atlas chat deals with Darija written with mixed Latin number words. I mean, the language that we use in our SMS or in social media.
Atlas the model or in the selection of the training data?
No, the model, the chat.
The model, if you prompt it in Latin script Darija, it will respond in Arabic script Darija. If you prompt it in English, it will respond in Arabic script Darija. So it always responds in Arabic script Darija, but it answers Latin script Darija. It understands English, so you can prompt it however you want. And for the training, we only trained on Arabic script Darija, and for Latin script Darija, we only trained on it for transliteration. So you give it the Arabic script and Latin script, and the model learns how to map the two. So I think that answers.
Yeah, thank you. Yeah, it answers. Thank you for your answer, Yousef. And we have another question regarding the evaluation. So did you compare the results with the closed source models? Like we saw that you use it like the Claude Sonnet in like generating data. Did you compare with it, or like it's hard to get to evaluate those models, the closed source ones?
Let's say it's in our plan, but following the common practice, they are somehow not comparable with us. As like I think it's in our plan. I mean, to evaluate with the like Claude or OpenAI ChatGPT. But in the end, I mean, we remain open source and the weights and are publicly available, so people can work on the extension of Atlas chart, fine-tune Atlas chart. I think this is something that ChatGPT or Claude that cannot offer on this level.
Okay, thank you for your answer. So this leads us to the last answer that we wrap up the Q&A. So first of all, thank you for your presentation, for all the work that you have been doing for Darija, for making these LLMs accessible to Moroccans. And the last question is, what are the next steps for Atlas Chat?
Yes, so I mean, if we have like we were still looking for more like Darija resources. For instance, Darija is a spoken language, right? And there must exist some audio data. So we can consider to develop a speech-to-text model, right, to gather more data to release a second version of Atlas Chart. Or on the other hand, we can think about a multi-model model, right? That one model that you can just directly talk with this model, like in voice, right? And then it generates Darija in voice as well, because in the end, Darija is mostly available in the speech format rather than text. I think that could be interesting as our next steps for test chat.
Yeah, looking forward to this next step. So this ends up our Q&A session. Thank you very much for this great talk. Thank you for the attendees. So now I will stop the streaming and we will go to the breakout sessions.
Thank you.
So I need to join this AMA with